Welcome back, everybody, for another deep dive. This time we're taking a look at something that even people who've been into tech for a while find super interesting. We're talking about generative adversarial networks, or GANs for short. And, you guys sent in this original research paper from 2014, which is really cool because this paper is like the beginning of so much of the AI stuff we see all around us today.
It's crazy to see how much stuff came from this one paper. Yeah, it's like the acorn that grew into like a whole forest of AI companies.
Okay, so let's say you're not like coding neural networks all day. How would you explain the idea of GANs, like the basic idea?
Well, imagine like a counterfeiter, like someone making fake money. And they're in this like big battle with a detective. So the counterfeiter, we call that the generator. They're trying to make fake money that's so good it completely fools the detective. And the detective is called the discriminator.
So it's like a game of cat and mouse.
Yeah.
Right. The counterfeiter's getting better at making the fakes,
Yeah.
and the detective is getting better at spotting them.
Yeah, exactly. And the cool thing is this like back and forth battle makes both of them better. Like the generator learns from the discriminator's feedback, right? So it gets better at making the fakes. And the discriminator gets better at spotting like really tiny flaws because it's always seeing like better and better fakes.
It's such a smart way to train AI. So, but like, how does this work for real? Is it like they have little neural networks fighting it out in some computer world or something?
Well, it's not exactly a computer world, but yeah, you've got the main idea. So both the generator and the discriminator are neural networks, and they're trained with this thing called backpropagation, which is like a really common technique in machine learning. And the elegant thing is they didn't need to use those really complex statistical methods that a lot of other generative models need.
So they found a simpler way to train these AIs to become experts. One is an expert at creating stuff, and the other is an expert at, like, spotting the fakes. That's super fascinating. But what makes this whole process so powerful? Why has this one idea been so important for AI?
Well, one big reason is this paper actually like explains the theory behind why GANs work. So they proved with math that if you have enough data and enough computer power, this training process can actually lead to the generator perfectly copying the distribution of the real data.
Wait, hold on. Copying the distribution, that sounds pretty technical. What does that actually mean?
Okay, think of it this way. Imagine you have a bag of marbles, and all these marbles are different colors. And you want to build a machine that can make new marbles. And you want these new marbles to have the same colors as the ones in your bag, like the same mix of colors. That's kind of what the generator in a GAN is trying to do. But instead of marbles, it's dealing with like images, sounds, or even text.
So the generator isn't just trying to copy like individual examples. It's trying to learn the secret formula behind the original data, right? Like it wants to understand the patterns and how everything is connected.
Yeah, you got it. And the way it measures how close it's getting is by minimizing something called the Jensen-Shannon divergence, which is a fancy way of saying it's measuring the distance between its generated data and the real data.
Okay, so we don't need to go full math nerd here, but it sounds like there's some serious math going on behind this whole process.
Oh, there is. And that's part of what makes GANs so good at producing those like super realistic results you hear about.
Okay, so they had this amazing idea. They figured out the math behind it, but then they had to test it outright. What were some of the first things they tried generating with these early GANs?
Well, they started with a classic data set, images of handwritten digits from something called the MNES database. It's basically a bunch of pictures of those numbers you see written on checks and envelopes.
Oh yeah, I've heard of that. It's like the first data set every machine learning person works with. But pictures of handwritten numbers aren't exactly like the most exciting thing. Did they try anything harder than that?
They did. They also worked with data sets with images of faces and even more complicated scenes with stuff like cars and birds and dogs.
So they really wanted to see what these early GANs could do. But how did they even know if the GAN was doing a good job? I mean, figuring out if something is making good new data seems a lot harder than just classifying existing data.
You're totally right. Evaluating generative models is a big challenge in AI research. Back then, in 2014, they were using techniques like Parson window estimation, which is like trying to measure how similar the generated data is to the distribution of the real data.
So it's like comparing the fake marbles to the real marbles to see if they have the same mix of colors.
Exactly. And the paper doesn't actually show us the images, but it does say the results were pretty good for the time. It was like a hint at the amazing things that GANs could do in the future.
It's crazy to think this was all happening back in 2014. So they had this powerful idea, they tested it out, and it seemed to work. But were there any, like, early warning signs, anything that made them worried about this whole GAN thing?
Well, yeah, they did talk about some challenges. One of the hardest things is keeping the generator and the discriminator in sync while they're training. You see, if the discriminator gets too good too quickly, it can actually like stop the generator from learning. Like imagine our counterfeiter working super hard, but the detective's just like way too good. The counterfeiter might just give up because nothing they make can fool the detective anymore.
That makes sense. It's like they have to work together, you know?
Yeah,
If they get too far apart, the whole thing falls apart.
exactly. And they had this really interesting way of explaining it in the paper. They called it the Helvetica scenario.
Helvetica scenario.
Uh,
Now you have to explain it.
okay, so imagine the counterfeiter. Instead of trying to copy all those little details on real money, they just start making like one super specific type of fake bill over and over again. It'd be like if you had a font, but it only had one style, like Helvetica, and it couldn't change to fit different situations.
So the generator's kind of like stuck in a rut. It's making fakes that are good enough to fool the discriminator. But they're all kind of the same. You know, they're not very interesting.
That's the worry. We want a generative model that can make all sorts of different creative stuff, not just one boring thing over and over.
So gens have to walk this tightrope to keep everything balanced. But reading through this research, it seems like they were pretty optimistic about the whole thing, you know? Like they thought the good stuff outweighed the bad.
Oh, for sure. One of the biggest pluses is how efficient they are. Unlike some other models for making stuff, they don't need those super complicated sampling methods, like Markov chains.
Markov chains. Can you give us a quick explanation for those of us who didn't study statistics, you know?
Good point. So basically, it's a way of modeling things that happen in a sequence, but it can take a ton of computing power. The cool thing about GANs is they just skip all that complicated stuff, which makes them way faster and more efficient to train.
Speed and efficiency are always good things in computing, especially when you're dealing with like huge amounts of data. What other advantages did they mention?
Well, GANs are also really good at modeling what we call sharp distributions. So imagine data that's all clustered together or has really unusual patterns, almost like a fingerprint. GANs can handle that kind of data without any problems. Some other models really struggle with that.
So they're kind of like the off-road vehicles of generative models. They can handle the rough stuff that would trip up other models.
Yeah, exactly. And because they don't use those Markov chains, they can explore a much wider range of outputs. So they can make more creative and diverse things.
This is all making sense now. They had this great idea. They figured out the math to make it work, and it can handle even the most complicated data. No wonder people got so excited about GANs.
And that excitement just grew when they started talking about all the potential applications in the paper. They didn't just stop at the basics. They went on to explore some really cool ways to extend the whole GAN framework.
Like what? Give us a sneak peek into the future they were imagining.
Well, one idea was conditional generation. Imagine you could give the GAN some specific input, like a description, a mood, or even a musical style, and it would make something based on that. So instead of just generating random faces, you could tell it to make a face that looks happy, or a face that looks like a specific celebrity.
Whoa, that's taking it to a whole other level. It's like giving the AI a creative brief and seeing what it comes up with. What other extensions did they talk about?
Another cool concept was approximate inference, which is basically figuring out how to reverse the generation process. So let's say you have a GAN that can generate faces. With approximate inference, you could try to figure out what settings were used to make a particular face.
So you can show it a picture of someone and can tell you how to tweak the generator to make a face that looks like that. It's like reverse engineering the AI.
Exactly. And maybe the most exciting one, they talked about using GANs for something called semi-supervised learning. So that's when you only have a little bit of labeled data, like images with descriptions, and you want to use GANs to make other AI models better at things like classifying images.
Wait, so GANs can not only make cool stuff, they could also help other AI models get better at their jobs. That's amazing.
That's the idea. It just shows how flexible this whole adversarial training thing can be.
You know, reading this paper, it's amazing how much they saw in this idea even back then.
Yeah.
It's like they were setting the stage for a whole new era of AI.
Totally. It's like they planted a seed and now we're seeing this incredible forest that has grown from it.
I love that analogy. And speaking of seeing, we've talked a lot about the ideas behind GANs, the theory, the challenges, the potential. But I know our listeners are probably curious about what GANs can actually make.
Right.
So the next part, let's dive into some of the amazing applications of GANs and see how this technology is changing the world around us. Okay, so welcome back to the show. We've been talking about GANs, and starting with that research paper from 2014, it's crazy how much this one idea has changed AI. But I feel like we've just started to understand it, like what about everything that's happened since then? If that paper was like the seed, what does the AI forest look like now?
Oh, it's a jungle out there. And it's been amazing to watch this whole field just explode with creativity. Since 2014, researchers have been taking those ideas from the paper and running with them, coming up with new GANs designs, new ways to train them, and like mind-blowing applications.
Okay, you got to tell us.
Yeah.
What are some of the things that have you like super excited?
One area where there's been a lot of progress is making GANs easier to train and more stable. Remember how we talked about keeping the generator and the discriminator balanced? Well, those early GANs were like notorious for being hard to train. They would do things like mode collapse where the generator gets stuck, and it just makes the same limited stuff over and over, even if it's technically good enough to fool the discriminator.
Yeah, the Helvetica scenario.
Yeah.
So are you saying researchers have been working on making JANs more reliable?
Yeah, exactly. And they've come up with some really clever ways to do it. Things like Wasserstein GANs and spectral normalization.
Yeah.
Those have been huge. They've made training way more stable. And the generated stuff looks better too.
That's awesome. It's like they gave these AI models better tools and a better gym so they can reach their full potential.
Mhm.
So with these improvements, what can GANs make now? We've talked about realistic pictures and videos, but is there anything else that's like pushing the boundaries?
Oh yeah, for sure. It's almost easier to ask what GANs can't create at this point. We're seeing them make everything from music and text to 3D models and even like whole virtual worlds. There are GANs that can write new music in different styles or write creative stories or design objects you could 3D print. It's crazy.
It sounds like AI is becoming like a creative partner, not just a tool, but something that can work with artists and designers and inspire them.
I think that's a great way to put it. And the really exciting thing is we're just getting started. For
Man,
example, people are starting to use GANs for things like personalized medicine. Imagine being able to design treatments just for you, based on your genes or your medical history.
whoa, that sounds like something out of a sci-fi movie. But it's a good kind of sci-fi, right? We could use AI to make treatments that are perfect for each person instead of just using the same thing for everyone.
Exactly. And that's just one example. We're also seeing GANs being used in robotics and self-driving cars to make realistic simulations of the real world. So you can train AI systems in a safe environment before you let them loose in the real world.
So they're not just helping us make cool stuff, they're also helping us develop other AI technologies faster. It's like AI is helping itself get better.
I like that. And I think that's a great thing to remember from our deep dive into GANs. This one idea from that 2014 paper has started this incredible wave of creativity and innovation, and we're just starting to see how much it's going to change the world.
It's been an awesome journey. We went from the basic ideas behind JANs to all the amazing things they can do. And it's clear that this tech is going to change the way we create, learn, and just interact with the world.
Huge thanks to our expert for taking us on this trip.
It was my pleasure.
And to all our listeners, thanks for joining us on the deep dive. We hope this got you thinking about the future of AI and all the possibilities. Until next time, keep exploring, keep learning, and keep diving deep into all the amazing knowledge out there.